Unfortunately, with this one, you have the silver mirror, you have to hold the pen just right. So we got it to work twice earlier today, and now it's being a little stubborn. We'll let it sit for a while. Maybe by the end, we'll see if something happens. So we'll just come back to that one later. So our reactions are this one continues going through. Anybody been counting how many changes it went through?
Like,
How many?
I don't know.
You know that?
I would guess like 50, maybe.
It usually goes through about 10 or 12. We've got a little bit more here. It may go a little bit longer. So it'll eventually quit changing colors. You notice though, did you notice anything about how it's cycling, how it's changing? Is it going faster or slower?
Lower.
Part of it's slower, part of it's faster. This color is kind of staying longer. It's going slower. Now it's coming back into the orange.
And the pink isn't there at all anymore.
So now we get that night, and there it goes again. So that part is kind of speeding itself up until it just kind of wears itself out and it just quits.
Now, honey.
So that's our oscillating reaction. We'll let it go for a little bit longer. Okay. Polymers. This segment, we'd like a volunteer. Oh, all right. First hand that's on the left. Okay.
Sit right in the chair.
Here, why don't you put it right here in the middle? Okay. All right, so there's our volunteer. Now, I want everybody to kind of keep an eye over here. Now, this is just water. We put a little food coloring in there so you can see it a little easier, so you see how much there is. Okay? I'm pouring a cup. Okay, it's the shell gauge. Keep an eye on that cup that I poured the water into. Okay, did you keep an eye on it?
Mm-hmm.
Okay, I'm going to take a cup and pour it over his head. Which one do you want me to pour?
I'm not down to the wall.
You want this cup?
Yep.
You kept a good eye on it, right? It's the water? Okay, you brought an extra shirt, didn't you?
No.
No? All right, here we go. Here we go. Nothing. You picked the wrong cup.
I see what's in there.
What about these? You think it's in one of these? Shall I try these? Oh, you guys didn't keep a very good eye on it, did you?
I did.
You did? Okay, anybody know what's going on here? Oh, what?
I saw the blue in the bottom of the cup.
Okay, you saw
And it
blue?
was the water, and you had a polymer in the bottom of it.
There you go.
And it absorbed the water.
Uh-huh. Anybody have any idea what kind of polymer this is? Where you may have seen this before? Diapers, that's right. This is the stuff that's in diapers. This is sodium polyacrylate. Okay. This stuff can absorb about 300 times its own weight in water. So I had just a very thin layer of that powder in the bottom. You probably wouldn't have seen it. I had to look twice to figure out which one it was. And it took up all of that water. So diapers are pretty incredible things. Okay, so you can see it now. We put the blue in there. It makes it a little easier to see. This is also used in diapers. If you've also seen, they have things for growing plants without soil. Okay, same kind of stuff, just bigger chunks. Now, what you don't want to do with this, does anybody know how you get the water back out of it?
You let it sit.
Well, you can let it sit. The water will come out eventually. Or you can put some salt on it, and the salt changes the reaction. It lets the water come out quicker. So what you don't want to do with diapers is salt. Okay? Okay, now if you'll promise me that you won't put your fingers in this or taste it or anything, I'll let you take that home. You can dry it out and try it again, okay? All right.
Okay.
Okay, don't touch it. All right. Okay, now for the next portion of our polymer demonstration, we need 2 more volunteers, 2 different ones. Okay, here's one right here. Okay, you want to come down? Come on.
I didn't raise my hand in time.
Okay, we're going to have a race. Okay, we've got our 2 beakers here. Okay, and we've got 2 piles of those styrofoam packing peanuts. All right, and what we're going to do is have these 2 guys race, these ladies and gentlemen. Okay, we're going to have them race to see who can fill their beaker fastest with the styrofoam peanuts. Are you ready? Okay, so get them in there, pack them in there tight until that beaker's full. Mark, get set, go. Okay, push them down in there, get them in there, get them in there. Hurry up, keep filling the beaker, get them in there. Go, 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 go. Go. Get them in there, get them in there. All peanuts in the beaker. You pushing that? Come on, come on. Can you get them all in there? Come on, you got a bunch more of them.
It's all breaking down.
That's the idea. You want to get them all in the beaker. Put all of your peanuts in the beaker. I think you're going to have to help him. Can you get his peanuts in the beaker? No, in your beaker. Can you put them in there? Look how many peanuts she got in this beaker.
I think it's breaking
Yeah,
up.
is it breaking up?
Probably all the acid. Probably.
Well, I think we have a winner. Do we agree? Okay. Do you see that big pile of peanuts? All of those are in this beaker. And what does that look like? Can you describe that to everybody?
Very greenish.
Very greenish. Kind of gooey looking?
Yeah.
Okay, so styrofoam peanuts are mostly air. Okay, it's a polymer known as polystyrene, and they just puff air into it. They foam it up to make these styrofoam peanuts. And if you have a way to get the air out of this, you can pack it back down into a nice tight little polymer. Okay, now it looked like we had a couple of beakers of water, but we didn't really. We kind of set you guys up. Okay, that beaker was water, and this beaker has acetone in it. So if you've ever used static. There. If you've ever used fingernail polish remover, you've used acetone. If you've ever accidentally spilled it on any kind of plastic and you see it kind of bubble like that, you know what's going on there. Okay, so the acetone breaks it down. So thank you both very much. Okay. And actually, we can eventually probably get all these peanuts in there too. We can get that whole pile in there. So we'll leave a few if anybody, don't touch what's in the beaker, but if you want to throw one in, you can see what happens to that. Okay, and then for our grand finale here, we want to show you. Okay, we're going to play with a little bit of liquid nitrogen. Anybody ever played a little bit of that? Yeah?
Yeah.
Okay, we use liquid nitrogen in the lab to help keep instruments cold and help keep different experiments cold, things that we need to have at very cold temperatures. This stuff, it's really, really cold. Liquid nitrogen is basically the air that we breathe is mostly nitrogen. There's a lot of oxygen and stuff in there too. But when you take air, that nitrogen, and get it really cold, you can turn it into a liquid. Thank you. Okay? But as soon as it warms up, as soon as we pour it out, and it hits this nice warm temperature out here, it turns back into air. It goes back into a gas. Okay, but while it's still cold, we can do lots of fun things with it. So for instance, there you go. Lovely rose. Just go ahead and see if we can get that in. Okay, so everybody knows what a rose is like, right? It smells good, nice and soft. We're going to see what happens when we put a rose down liquid nitrogen. It's got to be in there for a while. Leave it in there for a little bit. Stir it around. Nice little stirring stick. Ready? Try and see. Okay, we're going to get a rose nice and cold. Let's see what happens if we hit it on the table. Shattered.
Cool. What is that?
Nice.
You little kid.
Oh, we've got more roses here. You want to do another one? There you go.
I just remember this time.
So, ladies, the next time he messes up and brings you roses, don't accept the apology. This is what you do. Okay, so while that one's chilling out, we've got a couple of other things we're going to try. Anybody know what this is?
Yeah.
What is it?
A racquetball.
A racquetball, right. It's a nice bouncy racquetball, isn't it? Okay? So we're going to see what happens to our nice bouncy racquetball when we put that into some liquid nitrogen. Try that one. Okay, here goes the nice rose. There it goes. Okay, now we've just got a little crock down in this sink to hold some, because I can't quite get a racquetball down in this dewar that holds our liquid nitrogen. Keep going, keep going.